Okay, well, good evening, everyone. Thank you very much for the introduction. Today, I'm going to talk about kind of what we do and why we do it. So we are interested in basically brain blood flow. And to get an idea about why this is important, why this actually matters, just imagine a very active city, a busy city. It's bustling with activity all the time, 24/7 active. And all the time, I mean, there are always trucks bringing resources in, and there are garbage trucks taking the waste out. Imagine the same city, but now that what is happening is that they start becoming erratic. I mean, the supplies aren't coming, and as well as the garbage starting to accumulate. And then you start to have these jams that aren't necessarily helping the people who are living in the buildings in this city. This is basically what would happen to your brain. So in a brain that is healthy, what will happen is that you have all the buildings, the neurons in your brain that are receiving the blood supply from different regions and through blood vessels. And then during disease in a neurodegeneration, for example, what will happen is that your blood vessels aren't working necessarily as they should. So in fact, I mean, there has been huge effort over the years, and this has been a big dream for scientists, I mean, to have a map for the brain, to understand the buildings that are making the blocks of this brain. So these buildings are basically the neurons in your brain. And in fact, I mean, work from UVM, as you probably all heard about last year, I mean, has kind of managed to kind of characterize the map of the brain of a fly. And this is a step that is a major step, really, that we are starting to understand all neurons and their connections and all of this. Effort as well has been kind of going on for the human brain, the mammalian system. It hasn't yet been solved in general, but it's a major effort that we are all trying to do in order to understand what happens during neurodegeneration and what happens in a healthy brain, and then when things start breaking down. What is missing from both of these, and this is kind of huge effort that is happening worldwide, not only in the US, is the fact that we are only looking at the buildings in the city. We are not looking at the routes that will be essential for providing all of these supplies. The supplies as well as taking rid of the waste that is coming from this city. This is where our research here at Larner College of Medicine is going about. So the example that you're looking at here is kind of a great example by one of our talented grad students sitting here. So Asser Bidair, who is a PhD student. This is an example where we are trying to really image these tracks of blood vessels within the brain of a mouse. So this is an example that you're looking at here, that this is a mouse under anesthesia. We inject these mice intravenously with a dye so that we can look at their blood vessels. We can start kind of looking at different components. We can see veins on the left, you can see arteries on the right, and we can see capillaries that are very, very tiny. But now we have the resolution that we can actually tackle questions like this. This is important because this is kind of, again, the infrastructure, the angioarchitecture that would provide for all of these brain regions what they need. Not only we can look at this, we can also look, I mean, closer. And when you're looking closer, what you have here is we can actually start looking at the traffic. Not only the structure, because in neurodegeneration, even if the structure changes, this is not something that we can actually tackle, but what is important, the traffic of this blood that is happening in different places. What you're looking at here, you can see some black shadows that are kind of going consequently, and these are actually blood cells. These are blood cells that are passing through a capillary. And we can start to understand that some of these capillaries, for example, have very slow traffic, like the ones on the southeast here, versus one with very fast traffic, like the one that here at the top. So this is very important because we can now understand not only basically the routes that where kind of the traffic will be happening, but the traffic itself that is happening. Not only we can do this, we can also start understanding how the neurons that are actually stimulating all of these responses are sending the signals and how these blood vessels are sensing these signals. We can also see traffic jams. We can start seeing kind of when capillaries or blood vessels are they stop kind of passing the blood as they should properly. So all of this is really important. Why we do what we do, and why should I care, and why should I think you care as well? I mean, what we are doing here is not necessarily only about mapping a brain. I mean, this is a great kind of thing that we are really interested in doing. But the reason for doing this is because, I mean, the fact that our brains are functioning properly and the blood supply is working as it's supposed to is kind of a way for us to maintain our memories, to maintain our kind of livelihood in general. I mean, to be able to do everything that we are doing on a daily basis. Everyone here in the audience, I would assume, probably knows at least one person or more that have neurodegeneration, someone that you love, someone that is very close to you, someone that you have lost. I personally have multiple examples that I can talk about, but this is something that is affecting every single one of us. And by understanding how the traffic works, how blood flow happens in the brain, this is kind of the very first step, I think, towards this. Not only we can understand what happens and how things break down, but we also start trying to really clear the jams or try to improve blood flow in different brain regions so that we can achieve what is needed to be achieved. That's what keeps us busy here at UVM with a great team of students and postdocs in our lab. And with that, I thank you very much for listening. Thank you.